This is the Math Map Book Club, where ordinary parents encourage one another to develop a extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Welcome, everybody. I'm Leigh Bortons, and it's Wednesday, May 8th, 2024. Welcome to the Math Map Book Club, where my screen just knocked me out from my script. So I'll do that all over again. But welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. Kirsty did such a great job over the spring going through the lessons one by one, and now we've begun our summer series and looking at things by dimension. So what do you have for us today?
Well, I'm excited today to talk about calculation and all the ways that we can practice calculating beyond just the lesson pages.
There certainly are a lot of ways to calculate.
There are indeed. Uh, as we said last week, we really want this summer book club to be a relaxed format. And so while we do have some things planned to share with you, our first priority is making sure that we're answering all of your questions. So does anybody that's on our call today have questions that they would like to start off with? All right. Well, as you see here, we've got our math map up and we have highlighted the four domains that we currently have available. Complex is the only domain that is available in its entirety in its printed form, but digits, naturals, and fractions are all available digitally. And today, as that shading also points out, we are looking at the first dimension. And so that's why we're going to talk about calculating, because when we think of the first dimension, we most often are thinking about arithmetic. So before we get in, I did our first Math Map help desk calls this morning for Challenge A tutors. And one of the nice things that one of our guests said was that she said this was the most supported she's felt in her entire time with CC, that she really feels very supported. And so I was encouraged by that. And I just thought I would share that the number of ways that we want you to feel supported, whether it's the companion, whether it's being in community with other people that are using this curriculum, whether it's here, whether it's our email or talking to one of our curriculum assistants in the forums. There's so many ways that you can get help. And so I just wanted to encourage everybody, please don't ever struggle alone at home. Bring your questions to our book clubs on Wednesdays, or email them at classicalconversations.com, or jump on the forums. Take advantage of the support that's available to you, because we really do want you to feel supported and to get your questions answered.
So I have a question. So I'm not a Challenge A director, but is there any way to, like, are those videos, are they, like, is there any way we can get a first layer of, do you understand what I'm asking? I haven't really asked a complete question, but.
Well, what we're doing for the tutors is really emphasizing what they need to lead in class. So I don't know that it would be helpful for parents at home to see that equipping, because it's really emphasizing how they can use the math map in community
As a director.
in their seminar as a director.
Yeah, I guess that's what I'm interested in, is as a director, just equipping myself, because I want to know what that looks like in class. And I'm trying to be patient, but yeah.
Well, that comes partly, Jana, from us having 2,000 of them to equip. And so our priorities there with our Challenge A tutors. And the next year, of course, we'll do the same thing with the A and the B tutors. And so, and then as Kirsty does better and better equipping and moves through the process, she keeps adding more and more to the companion, so everybody can have access to the important parts.
All right. Any other questions? All right. So one of the last week we talked about teaching math classically because that's been a common question that we've had. Another common question that we've had from people is what about calculation practice? And a lot of your traditional curriculum emphasizes lots of calculation practice because the emphasis isn't on learning the language of mathematics. It's not even really on the concepts of mathematics, but success comes from being able to calculate well. And if you think about the math tests that you have taken or you've given to your students, typically those tests are calculation driven. Did you learn the steps and how to calculate or solve, right? So whether we're using numbers or letters in order to get an answer. While that's a very important part of mathematics, it's really half the story. And if you've been with us for any time, you know that the other half of that story is learning the language of mathematics. And as you learn the language of mathematics, you're going to start to encounter those concepts and those ideas. And again, they're interwoven, the ideas and the concepts with the calculations. But in a curriculum where we're really trying to emphasize doing so and grammar, um, may mean that you see questions that are important but aren't always calculation. And so some parents have said, well, what if I want more calculation practice? And so we wanted to talk about ways that we could calculate. Um, Certainly, we calculate all the time as we go through life. So before we jump into some of the more formal ways we can practice, I thought we would just brainstorm as you go through your life on a daily basis. What are some of the calculations you do, and where could you challenge your students to calculate alongside you as you go through the day?
Definitely in cooking.
It's a great example.
We do it when we grocery shop a lot.
Mhm.
Yep.
Time, like in 5 minutes and 10 minutes, just and you're now in what is that, base 60? Am I right?
Yep.
So
That's right. Yeah.
it's tricky for
That's a
me.
great point. Not just calculating, but calculating in a different base. Great.
Yeah, talking about mileage and driving distance and all the things while you're in the car.
Good.
So we had an interesting conversation this morning about hobbit age because my daughter noticed that it seems like hobbits age differently than humans. And she had noticed that, okay, so an adult is like 33. And so she was like, well, then she was thinking about, well, maybe hobbits, like human age is like -4. And then we compared that to, well, how old was, I think it was Bilbo when he was old. And like how that, like we do -4, that doesn't seem quite right. So she actually had her set up a proportion and kind of figure out, okay, so what might the proportional age to human years to hobbit years be? And then she figured out her age, and it was just a really fun connection. And we don't know if we're right. We figured, I think we probably need some more data points to make sure it's not like, okay, do they age more quickly as they get older or slower? Like, is it, we don't know.
Or maybe
Very, that's
Bilbo.
beautiful.
He didn't
It
age
was
as
fun.
fast because he had the ring, right?
Right. Yeah, I don't know. I don't know.
I love the fact that there's so much richness in that you are computing, but you are also talking about what's the best way to model this, what's the best way to figure this out. Is subtraction better, proportion better? The fact that you can sit there and say, okay, well, more points would give us greater accuracy. I just think that's a brilliant conversation to have. And to me, that's the type of mathematical literacy that we really rejoice when we see in our kids, right? Not just being able to go through a drill sheet, but be able to have those conversations. That's beautiful.
Kirsty, you made me think of something. Maybe we could make an analogy over the next few weeks to math studies with like writing studies. For example, maybe calculations is to mechanics in writing, as uh, something in math is to the creativity in writing. In other words, I can get calculations wrong and I can punctuate wrong, But nobody in writing stops there. Like they go a lot farther past that in their conversations.
That's
I
great.
think
Yeah,
that's a
that's a good
lot.
analogy.
That's learning what is grammar, what is dialectic. You have to be
Mhm.
dialectic, and they're still wrestling. They're still wrestling with calculations. You're still wrestling with punctuation. So that's part of that stage and that part of learning.
Now, how about gardens? Is anybody planting a garden right now? Because there's some geometry involved in gardens.
Yeah, so once again, you're going to have those math calculations. How much does it cost for my seeds? How much square foot do I have? What's the ratio of fertilizer to new dirt and old dirt? How many worms should I go dig up? You have all those kind of numbers, but you are also doing that for much more than the numbers. You're doing it to feed yourself and to see beauty and for the joy of being outside. And so those are all ways the grammar helps lead to the art of whatever it is you're working on.
And you have the temperature to, make sure you're
Mhm.
what zone do you live in, and is it too early to plant this, or are you supposed to wait and, is this a fall crop or a summer crop or whatever?
Mhm. That's great. How about sports? How many people have kids that play sports? Are there calculations involved in sports? Right. Even just comparatively, right? Something that we take for granted is knowing who won a game, right? So the Celtics played the Cavaliers last night, and the Celtics had 120 points, and I think the Cavaliers had 94 points. So who won, right? And so we need to know a little bit about basketball that the higher score wins. But then I also, right? So we just instinctively, especially as adults, go, oh, well, 120, it's more, so they won. But with our students, right, asking them, well, who won? Or look at a golf match, right? Now it's lowest. So which number is the least? Ordering, right? So when you look at the leaderboard on the golf, right? Looking at um, there's two different ways, right? Do they look at their total score, in which case I want to go lowest to highest, or do I look at their score under par, in which case I go from still lowest to highest, but magnitude I'm going usually the greatest, right? So there's all these conversations that we can have just throughout our day when it comes to calculating. And so we really want to encourage everybody because it's tempting for us to think we need to, this is our math time and we need to sit down and we need to have our books open and we're going to do our math, right? But when it comes to calculating and developing that fluency of calculating and that comfort with calculating, just recognizing that we're using numbers all the time and we're calculating all the time, I think can really help our students um, just become more comfortable and confident, and then helping them see that what they're doing all the time at home when they're doing that is the same thing that they're doing. That's the same thing they're doing in their math pages, right? Helping them to make that connection. Because, we probably all know a student who says, I love to learn, but I don't like school. Right. And so them bridge that gap is something that we can do too.
So
Right. Any
yeah, I was just wondering, my boys are in Boy Scouts and they do orienteering. So they're calculating degrees, right? Of where to go. So I don't know if that would be considered something.
Yeah, that's perfect. I mean, orienteering, when we talk about our coordinate systems, right? And we talk about polar coordinates, that's exactly what they're doing. So that's great. That's
Anytime you're
great.
pointing to a tree or a bird or something down the road, you actually are intuitively using polar coordinates. You just, nobody told you.
Right. Well, let's look at some of the more formal ways that we could practice calculations and especially some of the tools that Cece has. And the first thing I've broken it down, and the first one we're going to talk about is addition facts. And that's probably something that we all commonly use as we are going through life. But all addition requires knowing the sums of all the possible digit pairs. How many sums is that?
It's infinite.
Well, just the digits. So we have 10 digits.
Digits only pairs.
Yes. And I'm asking you a question that I haven't actually calculated. So I'm doing that in my head at the same time that you are.
Was it something with factorials to figure that out?
Well, it would be if we were not, if we didn't think you could add a number to itself. But if you add a number to itself, then
it's included.
It's right? So
Mhm.
how many possible sums are there with 0?
So there's 10 with each one, but then you have repetition of like 0 plus anything. So then there's only 9 with 1 and 8 with 2. And so, or no, it would be 9 with, no, it's 9
And
with
are
each
we-
of the
and are
rest, but
we-
then you still, no, it would be that. It would be going down. It would be 9, 8,
Yeah, so
7
maybe it
because
is
you've repeated
factorials.
those. Yeah.
Well, unless when you say 9 plus
That's
9
9.
and then say 9 plus 9 again, in your mind you flipped which 9 you meant. Then you wouldn't need factorials.
Right.
But if you're just
That-
counting them
that
as
one-
pairs, then like a pair is a pair regardless of the order.
Right.
So
In subtraction, that would order would matter, but for addition, it doesn't.
So if I wasn't worrying about the like 0 plus 0 and then there's 0 plus 1, but then I don't need to count the 1 plus 0, right? Because that's duplicated. So
Right.
essentially I would have 100 if I was saying the duplicates counted, but then how many duplicates am I going to have? I'm going to have 2 duplicates of each sum, right? Because of the commutative. And so how many do I have altogether? 100 divided by 2,
50.
50. Mhm.
50.
Somehow I got 45. Are we counting 10? I'm sorry.
No, 0 through 9.
0.
Oh, 0. Oh, yeah. Okay.
5 more.
That we were doing math. Thank you.
So there's lots of different ways we were all thinking through that and talking it out. One of the things I really want to encourage us, especially with our kids, is that our school mathematics is so frequently treated as an individual competition, right? Like it's an individual sport. Who can calculate the fastest? Who can get the highest score on the test, right? It's an individual, and you've got to figure it out. But mathematics historically, and any mathematics that you do, let me say most of mathematics that's done in the research realm where people are pushing the boundaries and saying, well, what else do we know, is done collaboratively. Not just one person toiling away at a whiteboard or on a legal pad writing away. They sit down and they talk about ideas and they say, well, what about this? And what about that? What if we tried this? And so what we just did there collaboratively, where somebody said, okay, well, there's 10, and then would there be this many? Would they be that many? And there's repetition, right? We're talking through it together and learning from one another. So I just want to encourage you that's what we're hoping that we're going to see more of in community and at home. Because now, right, if we're talking about addition, all of my students can talk about addition. They may be using different numbers. They may be doing different things. They may be using variables, but they're all talking about addition. And so we can have that conversation. But I just wanted to point out that there's 50, right? So there's 50 possible sums upon which all other addition is built, right? Students cannot add 103 plus 79 if they don't know what 3 and 9 is. And so it really, that is our essential grammar for all of our computation, are looking at all of those digit pairs and knowing those sums. Now, if we just stop there, we're always having to to work through some process of addition. And so that's why in our addition cards, we have the facts through 15, right? The more facts that I have rapid recall to, the faster my recall is of those additional facts, the faster my computation becomes, and the more likely I am to notice patterns in numbers when I'm familiar with those sums. So the addition flashcards are one of the best ways that we can start with our youngest children, helping them to know those sums. A lot of our kids are learning them just as we go through life, right? With our youngest students, a lot of times we're just always counting and we're using our fingers. We might be using our toes. We might be using objects around us to become familiar with those first 50. It makes me think of the spelling book, right? That like 95% or 1,000 of all of the words we use or come from 1,000. And so if we know how to spell those 1,000 words well, right, we're well on our way to being good spellers. So it's the same idea here. If we have these fundamental facts, then we're building on that. And that's what we do a lot of times, right? Just thinking through that with our students. And so now when we get the addition flashcards, we're helping them to go a step further. And then to do that in a fun way, we can use the Quickflip arithmetic that was developed by the Mandala students. Actually, it's scary to think how many years ago that was, Leigh. It doesn't feel like that long ago.
It was 11 years ago.
So they put together this great resource, and there's a chapter for addition and a chapter for subtraction. And notice here that because we look at addition and subtraction as really being the same, subtraction is the addition of the inverse. So I always lump those two together because if I know my addition, I'll be able to know my subtraction. Practicing my subtraction is going to help me with my addition. And so we have 2 chapters of Quickflip arithmetic that practices addition and subtraction, but using cards. Right? And there's a lot of ways that I can use cards to practice those basic addition facts, but I could also practice, right, an infinite number of addition fact cards. Right. So if you want to practice adding 4-digit numbers or 5-digit numbers, right, deal 4 or 5 cards out and create those problems. So there's an infinite number of numbers, and all we need is a little bit of chance to put those together into new patterns, and we have an infinite number of calculations that we can practice with our students. And chances are that your students are going to enjoy playing with cards more than they're going to enjoy doing a drill sheet. Yeah. Anybody want to share anything about addition facts before we move on?
I think that it's not so much the facts. Well, the 50 pairs, that just opened up a whole nother idea to me that I'm going to explore and maybe share later. But it's not just knowing the facts of those 50 pairs, which make everything easier for borrowing and carrying. So it's like you got these 50 pairs that shows you patterns. You've got borrowing, you've got carrying, and then you've got other symbols like summations and series. And so parents who think, well, I can add, and then they see summations or series symbol, that can feel frightening when all you're doing is continuing to add and you're looking for different patterns. And so even those can be memorized and practiced. So it just goes on and on through the calculus level.
Absolutely.
I don't know what I just said because I'm just thinking about it for the first time.
Well, but it's true, right? That there's so much we can practice, and we may think of addition and arithmetic as being just numbers, but I could certainly use cards and say, okay, well, red cards are X's and black cards are Y's, right? Well, now you have to combine your like terms, right? So now I've got 2 different variables, or maybe my black cards are X squared and my red cards are, or my black cards are reals and my red cards are imaginary numbers. So now I can build complex numbers. So or I've got 4 different things.
I got you
What are they
going.
called?
Yeah.
I know. There's four suits.
great.
Here we go. There's four different suits. So I could have four different variables. So there's so many things, or I could make matrices, right? And add matrices. So I'm trying to really encourage you that when we're thinking about addition, we know our basic facts and then practice in fun ways. And Quickflip is a great resource to help you get started.
I was just going to say, Kirsty, abacus. I just remember as a child, someone gave me an abacus, and I spent so much time like the one over here and the nine over here, the two over here, and seeing the patterns and then making the middle, just that I never thought about it until now that the calculations give you a language of describing a pattern instead of starting with the calculation. It's almost like if I could describe this pattern, I would use it through the language of addition. So I've never thought about it that way, but yeah, that's really
great.
Well,
and what you just said takes me back. So in 1999, which is more years ago than I like to think, I had the opportunity to attend the British Congress on Mathematics Education, and the time, and they still have a really big numeracy push. They have a whole website designed that adults can go to increase their numeracy. But they were really working hard on this national push towards numeracy for their students. And it seemed like everywhere I went in England on that trip, you would have kids that were just doing mental calculations everywhere I went. And they were, and they were fast. It was amazing. Grandparents, you'd be standing in line somewhere and a grandparent would be like, well, what's 432 times 96? And the kids would have the answers and I'd be like, wow. But one of the things they did, just when you said that, 1 and 9, 2 and 8, they called them number bonds. And so they knew if they knew their number bonds to 10, then they could know them to 100 and 1,000 and see that pattern, right? And so all of those things, you're exactly right. As we learn the facts and we observe the patterns, it's opening up all of that to us, this deeper understanding of the way numbers operate, as well as the calculations. So now I'm going to point out that multiplication requires knowing the products and the sums of those digit pairs. It's just as Leigh pointed out, when we carry, right, we're now adding. When we have double digit multiplication, we're adding. And so I need to know the products of those digit pairs. So again, if there were, am I going to have? Ten numbers. Sums, there's going to be how many products?
Wouldn't it be the same?
It'd be the same. It's going to be 50, right? So I just think it's fun because we keep noticing this. Leigh keeps saying, look, there's these fundamental things. There's just this one body. Know this first, right? So now I know my 50 products, which I could have calculated using skip counting, right? But I know my 50 products, and just like addition, the more that I know, the more rapid my calculation is going to be. But beyond my single digit products, I didn't write this on here, but we really emphasize it. All multiplication uses the distributive property, right? And so I really always come back to reminding people that once I know those products, anything more, I can remember them, right? I can do the math facts through 15 times 15, and that's going to help me. And there's going to be things that I remember, like 20 times 20, right? We're going to remember those and not necessarily calculate them every time. But anytime I'm multiplying beyond it, I am using the distributive property. And it doesn't matter how I arrange that. So it can be arranged vertically, like most of us are probably familiar with from our school days. It can be arranged in a way. It can be arranged like the Japanese like to, with crisscrossing lines, right? It can be arranged horizontally. The arrangement doesn't matter. It's all the distributive property. And so I always like to remind people of that, because our our language about mathematics, especially in our country, seems to focus on the arrangement as though the arrangement is different ways of multiplying, but it's not. It's just different ways of arranging the multiplication. And so we can find an arrangement that works best for us or works best for the particular circumstance. But the underlying idea is the distributive property.
And there's
So
only
always like
50 pairs to distribute.
Mhm.
And most of them are easy, right? 2 and 3 and 4 and 7. You know them all. That's really good. That's very insightful, Kirsty.
So just like, so we've got multiplication flashcards, right? So there's a great way. That's probably the easiest way when we're out and about. If we look at the catalog, it's like they're portable. They're in this sturdy box. We're out and about. We can play with our flashcards. When my kids were younger and we were still in foundations, how I miss the simplicity of those days. Um, right. I loved the flashcards. I loved my math flashcards, and I loved my memory master, my memory work flashcards. I'd have them on my ring, and we played so many games with those. We would, the one my kids loved the most was I would just hide them all over the house, and they would just go and find them. And then as they found them, we would practice them. And it was the easiest thing because it just had them running all over the place, and I didn't have to do anything. So it was a rest moment for me, but we also got to practice our grammar. So flashcards really give us a way of simply practicing, right, our memory work. But then Quickflip Arithmetic has a whole chapter that's dedicated to multiplication games. And so just like we did with our addition, we can take those quick flip games and we can extend them on to give us algebraic computation, rational numbers, right? All these different and create with cards and practice our multiplication. Anybody want to share any insights into how you practice multiplication at home, or have you used these resources? So these resources have been around for a while. Like I said, we use the multiplication flashcards, and Quickflip now has been around for 11 years. So these are resources that CC has had available. But if you haven't discovered them before, I encourage you to discover them now. Quickflip Arithmetic is a great resource to have on hand and take with you if you're going on a trip. Take Quickflip Arithmetic with you and a deck of cards, but it's also accessible through CC Connected. So everybody can go and pick out a couple of games that they really enjoy. So working through our 1D lessons, we talked about addition and subtraction, multiplication. I didn't start with working through and looking at comparison, but certainly you could pull out these ideas from Quickflip Arithmetic, right? Pull some of these ideas out and then compare. And that's what we're doing oftentimes, right? I deal a couple of cards and I compare the two. Or maybe I deal 2 cards on one side, 2 cards on another side. I add them and then I compare. So we're constantly practicing those comparisons as well. I'm going to point out that when I talked about addition and addition and multiplication, I have memorizing. But when I come to division, we've changed it a little bit to developing your division memoria. And notice that I said it requires knowing all the products and all the sums, right? And so again, if I don't know my sums, right, I'm not going to be able to subtract. I'm not going to be able to add in order to multiply or divide. So there is a progression of skills as we extend these, although certainly the memorization part is accessible to everybody, but extending it beyond that, there is a progression of skills that we're adding. I wanted to point out here that our flashcard deck is not called division, it's called fractions. And while in that fractions flashcard deck, which is new, We are going to practice simplifying fractions and looking at some fractions. We're also going to be looking at the different forms of division. I think that one of the hardest things about division is that there are so many different forms. And if we don't recognize are all asking us the same thing, then that's don't have the language to have a conversation. If I see a fraction that says 1/2, and I don't know that that's the same thing as 1 divided by 2, then I'm stuck, right? It doesn't have the same meaning. So part of developing our division memoria is understanding those different forms of division, able to translate between them and writing things into the form that's going to make the calculation the most straightforward and accessible for our students. But again, if we know, when we think about division, if we know our products and our sums, that's the best way that we're going to be able to calculate in division, is by knowing those first. And then we do have the fractions for forms, as well as some of the calculations. And then Quickflip has division games. Is there anything anybody wants to share about division? Because it's usually fraught with emotion.
I think I remind people is that remember that 2 of the forms are words and images. So we do have things where the students take, blocks and cubes and see the parts of them, or circles, or even objects for the little guys. But those are important to carry through, just in daily life with the older students. And then just saying 5 divided by 8 or 5/8. And Kirsty's real big on saying if you read the fraction problems, usually they get easier if you say them aloud.
What
Okay.
would you say to a parent who's wanting long division, more long division practice?
Keep your child in from recess. That's what happened to me.
Are you asking more than what we have in the pages of the Quickflip? I mean, of the math map, or because the Quickflip is
how do
meant to make up for a lot of that. There's long division problems that you can play with
Okay.
cards too.
I'm not as familiar with Quickflip, and I've only flipped through the fractions once or twice so far.
Mhm.
But I know that that's one of the things one of my parents was saying is my child needs more long division practice. And the only thing I could think of on the spot was, well, there's thousands of sheets of that on the internet and go do that. But I
Mhm.
think once you get the basics with the fractions, once you know the digits, then it makes long division easier. So it's just that additive, knowing one to get to the other.
I think we need to help each other get better at kind of what I still call car school, like working with your little one saying, okay, how many times does 2 go into 2? How many times does 2 go into 22? How many times does 2 go into 222? And then orally, just making more and more patterns that are so similar to each other that they start to see, oh, I just keep moving.
Moving.
Right?
Yep.
There's so much intuition that math games and conversations have that you don't get necessarily from paper when you're little, because children almost need to feel the beat of it. Isn't that crazy that I'm talking about that in math, but it's true.
Harvey. Yeah. Okay, Kirsty, this is interesting because I've always heard that multiplication is like the opposite of division, but it's not really. I mean, it's not like the opposite of, you're not doing it. This is much bigger than that. Would you say?
Yeah,
Yeah.
so hold that thought. I'm gonna give Donna another answer, and then I'm gonna come back to your thought. So for those families who they just want their kid to do long division, 2 things. One, remember they're going to see it every year, and it's going to be scaffolded year over year. And so they're going to work from in the narrower domains, they're going to see problems that work out more nicely with smaller numbers. As they progress through, they're going to see bigger numbers and right that take up more space. And then with our algebraic students, we're going to be doing polynomial division, which is a form of long division. So we're going to be building on that from year to year. it is something that takes a lot of space. And so instead of, right, in a consumable booklet, having pages that are just one long division problem, right, this is a great case where, hey, you deal your cards or roll your dice to come up with your numbers and just write it on a piece of paper and practice until you feel like you're confident your students got it. And yes, so we say that multiplication and division are inverses of one another, because if I said 2 times 3 equals 6, then 6 divided by 3 equals 2, or 6 divided by 2 equals 3. And so we do have this sense of the inverseness, and where we use that a lot is when we're solving. And so especially as we move into the monomials domain next year and we start to emphasize solving, we want to recognize if I have 4x, 4 times x, what's the undoing operation? It's division. So I would have 4x divided by 4, and I would do that to both sides. So there is that sense of the inverse. But we also keep coming back to, when we look at the order of operations in the math map, that we pair addition and subtraction, because I can write subtraction as addition and I can write division as multiplication, right? That 4 divided by 2 is the same thing as 4 times 1/2. And so there's times where division makes more sense. There's times when multiplication makes more sense. I cannot use the commutative or associative law with division, but I can with multiplication. So if I have a string of numbers and I have division mixed in there, I can't change the order up, even if it would make things more, easier. But I can rewrite those as multiplication problems. Now I can move things around and I can do whatever I want to make my calculation more straightforward. So there's a lot, well, as we start to see that entwined nature of multiplication and division, it gives us just a lot of control over our calculations.
Thank you. And I just learned something I had never known. Thank you.
So I'm going to go back. I just want to go back for a minute and mention here that we've talked about lesson 3, lesson 4, lesson 5, I am not going to talk about lesson 7 and 8 specifically, which is equations and exponents, roots, and logs, because we just don't have enough time. But we have in development, ready for next year, 2 more flashcards that will be exponents will be one, roots and logs will be the other. And so together, those 2 decks will give students that ability to drill some of the most common exponents, roots, and logs, and the relationship between those. In Chapter 5 emphasizes work through equations. Chapter 6 emphasizes exponents, roots, and logs. So courses that work for addition, subtraction, multiplication, and division are also resources that are going to work for exponents and then putting those together into solving equations. So all levels of students can have this practice that's outside of the lesson pages, them to build their fluency and their quickness of calculation. One thing I do want to point out is that our kids' brains are all different. And the more we practice, the faster we get. But some kids are going to be naturally better at processing faster than others. Some kids are going to their brains are going to be wired to calculate in their heads more easily than others. And so this is an opportunity for us as parents to really look for where are our students strong and encourage them. And then if there are things that maybe they're not as strong in, right, giving them practice there, but with grace. And so that's where, right, not everybody's going to be doing well at time tests and, how fast can you calculate? That may not be the best measure of your fluency, knowing your student as you think and how you want to use that in your homeschool. So those were all things that you could use from outside the curriculum. And those are really calculations outside of context, right? That's just practicing your calculations to build up that fluency. Also want to use our calculating in context. And so I've put some examples here for those of you who haven't seen the complex booklets yet. These are pages that are going to be included in all the printed materials. So if you are using any of the digital materials, you don't have access to these. But the last but 2 pages, including the back cover, is called the Careful Calculation. And this has calculation practice that is in context of the week. And so these all are from the those first few weeks. So they're practicing addition and subtraction and division. We continue throughout the year to have these careful calculation sheets. And so students are going to continue to have the opportunity to practice calculations that are related to that topic. Use this at home as a practice. You could use this at home as an assessment. You could cover this with a sheet protector and have your kids practice it each day if you wanted to. You could take these sheets and combine it with a pack of cards or a dice to come up with new numbers, right? So you might say, oh, these are really great problems, but I don't want to do the same exact calculations every day. So I'm going to copy these, but use different numbers, right? And I'm going to use a pack of cards to help me come up with new numbers. So notice how we can take all of these resources and take control of our own students' learning. And again, just like Leigh's always saying, don't let the curriculum use you, that we're giving you resources. But one of the goals of the Math Map is to really help parents feel equipped and empowered to teach their students at home. So. Another part of the curriculum that we have, back cover, where we have games and activities. And so I've pulled out here an example of a game and an example of an activity. I didn't necessarily pull the instructions out for the multiplication table. I did for the game, just to show that in the booklets we have some weeks, most weeks, we have a game on the back for students to play, and we include the instructions for a basic game there. Over time, the companion will have ways to scale these games. Those aren't necessarily there yet, but that's thing. And so you can see here, we've got this game called Justice that we've created. And so it practices that idea. It ties together with the art from lesson 3, where we have Justice with her scales. But we're using comparison. We have the multiplication table for lesson 5. And so there's another way, right, that we can help students to see those patterns of multiplication and learn those facts.
Are these games to use in community, like with your Challenge A class, or at home, or both?
They're really designed for at home, just because there's not a lot, right? You probably don't have a lot of time in community. Now, some of our pilot tutors may have used some of the games on days where they had something special going on, maybe as part of their Blue Book review or over lunch as a part of a special activity, but there really isn't time in community for the games. They're really designed for at home.
You know, we play National Number Knockout, and we have an integer game, and we have Quickflip games woven into the teacher's guide and the Challenge A guide for you to see. But they're really meant to be exordiums to kind of warm up the students, to just get them thinking in terms of calculation before they jump into the booklet.
Great, thanks.
All right. So there's a whole myriad number of ways that we can practice our calculation for all of our domains, right? Really, all of our domains can be included in these. So even though we're talking, when we think about arithmetic, we might think numbers. Algebra is a generalization of arithmetic, where we're looking at those patterns, and now with different units. And so all of our students can use these ideas as ways that they could be practicing at home. to increase their calculation efficiency. Just as a reminder, those digital versions that are available, and our print version now is available. I know everybody on here, you're here, so you know this, but I really want to encourage everybody that the expectation is that everybody is going to have the math map for use in community. And the reason for that is that we believe everybody's in CC because you want your children to have a rich conversation with academic peers about. And we recognize that even if everybody in your class is in the same book of sex, the chances that everybody is doing the same 4 lessons every week and stays on that pace is fairly small. And the way that Saxon sort of jumps around a little bit to create that review, it means if you're just off by a couple of lessons, you may not be doing the same thing as everybody else or the same thing that your tutor's covering. So the math map was really designed to meet a lot of goals, but the goal that it meets for our communities and the reason why we want everybody to be using the math map and have it in community is they can be talking about the same concept, the same topic, even if they're tailoring the materials at home. Because we're going sort of a chunk of things at a time, each week we're talking about the same ideas. Parents can tailor this curriculum to meet the needs of their students at home. So without moving slower or going ahead, they tailor it a little bit differently. And so that they can move at the same pace as everybody in their community, but tailoring it to the needs of their student. And so I just really want to make sure that everybody's heard that message, that if you're in CC, right, you're here because you want to have these rich conversations. And the richness of the conversation comes from that common experience. And the math map is what can provide that for the math strand. So all that said, what questions do you guys have left with our remaining few minutes today? Now, don't go and crash CC Connected because you're all going to jump on and look at Quickflip arithmetic. But that's a great thing to do over the summer, right? So this is a great time when we're in the summer is to go and get some of those games and just play with your kids as a family. And they don't even have to know that you're practicing math, right? Just pick some fun games and start calculating.
I have a math question for you.
Sure.
So my teenagers and I are working through the fractions level right now. And my 15-year-old daughter and I were specifically discussing dividing by 0. So she was having a hard time wrapping her mind around 0 being divided by 0, really sort of seeing that as an identity fraction. At least that's the way that I was picturing it, is that 0 divided by 0 would equal 1, just like anything being divided by itself would equal 1. And so she was having a hard time wrapping her mind around that because she was seeing 0 as being nothing. So how could nothing then become 1?
So I'm going to show you. So there's 2 words when we're dealing with 0. It's a funny thing, right? And there's 2. I'm just going to give you the big picture here, and then you can and see if it answers your question. So if I have 1 divided by 0, well, let me back up. Actually, I'm going to erase this. Let me figure out where my eraser is. Erase. There we go. 10. Okay. So if I have 6 divided by 3 equals 2, this means that 2 times 3 equals 6, right? And going back to what you were saying, right? That's this fundamental relationship between multiplication and division, is that anytime I say something's divided by, I could express it as a multiplication relationship. So what that means is that let's say I had 1 1 divided by 0, and I equal something. Let's just call it A. Well, that means that there has to be some A that makes that equation true. Is there any number A that would make that equation true? No, right? Zero. There's nothing that when I multiply it by 0, I get 1. And so that's why we say that this is undefined. That's why, because there is no way to make that relationship true. Now, that's when we're thinking about this arithmetically, if we're thinking about this in 1D, right? So I'm going to put 1D. Now, where we also see this is in 2D. And in 2D, I might have a line. And when I look at the slope of that line, it's the change in y over the change in x. Well, let's say from this point to this point, and so my change is 1, but my x didn't change at all. Well, if I was just looking at this arithmetically, I might say, well, that's undefined. You can't do that. But the line there, and the line clearly has. So as we'll see later on in calculus, we can use something called the limit. And we say the limit, right, of 1 over x as x. We can say, what happens there? I know I can't go 1 over 0, but I can sit there and I can say, okay, well, if x is 1/10, 1 over 1/10 would be 10. If it was 100th, it would be 100. So the smaller that my x gets, the bigger my number gets, and it's going towards infinity. And so historically, one of the other places that you see this is in trigonometry. So if you look at old trig tables, historically, people just sort of ignored this part and they said, well, when I'm talking about slope, I can just say it has infinite slope. And that's where that infinite comes from. Now, so there's our 1 divided by something, right? Or anything divided by 0. But then we have this weird case where we have 0 divided by 0. And we say, well, what could that be? And we say, well, we think it could be 1. And that means that 0 times 1 equals 0. Is that true?
Yes.
It is.
Yeah.
It is. But is this also true?
Yes.
Yes.
Sometimes.
It is. And so where the first case, there was nothing, and that's why we say it's undefined. Here, this could be anything. And so the term we use is indeterminate. Because I can't determine what that value is, right? Because it would be true for any value. So saying 0 divided by 0 equals 1, is it true? Sure, but 1 isn't the only thing that it could equal when we think about the definition of, or that relationship between division and multiplication. And so that's why we use that word indeterminate. So
This is also where circumstance comes into mathematics. So when people say I like math because it's always the same, and I think, well, no, it's not. Depends on the circumstance. Because even more basically, this is a little difficult, but more basically that there's you can't do the associative and commutative law in division the same way you can in multiplication. So your operation is the circumstance that determines what you can do. So math's fun.
Jennifer, did that help?
Yes. Yes. Thank you very much. That is great.
But meanwhile, what's better is to not know any of this and go to bed at night asking the Lord, how could 0 over by 0 be equal to 1? And let him answer you in the morning.
Yes, and our whole family has had great joy in discovering this. We've talked about this for several days now, and my kids had wanted me to jump on the math map today so I could ask this question. So
Great.
Well, I'm so glad you did.
Mm-hmm. Yeah, because 0 and 1 are like just the best numbers ever.
So for all of you who are sitting here I want to tell you one of my favorite Leigh quotes, and we ended up putting it in the math map, but I just love the fact that she said, I always love to see zero in a problem because I knew it was going to make it easy. And so for all of you who have think, oh, Leigh, she's this, aeronautical engineer, she must really like complicated equations and hard calculations. Rest assured that Leigh is just like the rest of us and is always happy when the calculation is an easy one to do.
Thanks, Kirsty, because I do like it when it's easy. Oh.
Well, thanks everybody for being here. Next week, we will be in 2D. And I have had the suggestion made by somebody today that it might be fun to look at what do some of these conversations look like when you have a natural student and a complex student together at your table. So bring your math questions, and I look forward to seeing you guys next week.
Thanks, Kirsty.
Thank you so much.
Thank you.